Hey everyone, today we're going to talk about nested loops. A nested loop is simply one loop that's contained inside another. And a good analogy and a way to think about this is if you think of an analog clock, like the face of the clock on this slide, the hours hand moves once for every 12 movements of the minutes hand. So you cannot go to the next hour until you complete all of the 12 iterations of minutes. And the same thing with the seconds hand. It has to move 60 times for each movement of the minutes hand. So you can think of all of these as one loop inside of the other, and you cannot go to the next one until you finish what's inside the first one. This is a little diagram that shows this, and you can see that up at the beginning you're going to start with a small oval, and the diamonds are decisions. So if you go to the first diamond, is there another value in the hours list? If not, then you end. Otherwise, you're going to assign the next value in the hours list to the hour variable. Then you're going to do the next decision, which says, is there another value in the minutes list? If there is, then you're going to assign that next value in the minute list to the minute variable and so forth. And you're going to keep checking till you finally get to the very inner loop down here at the bottom, which is going to print the hours, minutes, and seconds. So you know time is continuously changing, so this is going to happen quite often, but you're only going to print every time one of these changes. So you don't go to get the next hour till you finish both of the other loops and so forth. In our class, we're going to be using nested loops to draw grids. Because we use graphics in the CMU course, in graphical applications, a lot of times you want to draw things in a grid like this, and you can think of the game of Battleship. So how do we draw a grid of evenly spaced items? And that's what we're going to work on. I'm going to work you through an application, one of your exercises that's going to do this, and hopefully that's going to help you understand nested loops. Things you have to remember about nested loops. The inner loop goes through all of its iterations for each iteration of the outer loop. The inner loops complete their iterations faster than the outer loops. And the total number of iterations in a nested loop is going to be the number of iterations of the inner loop times the number of iterations of the outer loop. So that's how you figure out the total number of repetitions. And now we're going to take a look at the magnifying glass exercise and work through that so you can really see how to set up these nested loop structures. Before we do anything, we need to run our solution to make sure we understand what we're aiming for and how this works. So first thing you notice about the solution is you have your grid. So you know right off the bat that you're going to be drawing these circles, and you're going to be using nested loops to do this. And you notice too, if you move your mouse around, the magnifying glass is going to be following your mouse, and anything underneath the magnifying glass, and you can also think any intersection of some points on your grid with the magnifying glass are going to cause the circles to get bigger. So I already know that we have to use some nested loops to draw, and then we're going to be using some other functions to check to see if the circles are intersecting with any parts of the magnifying glass. So let's start out with the first step here, and let's put some nested loops in here, and then I'm going to talk about how these nested loops are going to work. So let's talk about the outer loop. And the outer loop is going to be controlling the changing of the x value. So I'm going to start out here, and if I look at my inspector, I can see that the first x value is going to be 40. And the x value is going to change, and we're going to increment by 40 each time we draw a new circle. So if I take 400, which is the total size of our canvas, and I divide that by 40 because I want evenly spaced dots, I'm going to come up with 360. And you should see that your last value is going to be 360 down here at the bottom and 360 over here on the right-hand side of your canvas. Now, you're going to stop at 360, and to determine the ending value of your loops, you're going to see that if you add 40 to 360, you're going to end up with 400. But you don't want your dots falling off the side of the screen. So for the ending value of your loop, you want it to really stop at, have the last position be 399, and that'll assure that it's going to stop in time. And we can try this out. If I change this to 401 instead of 400, and I run my code, you can see that the dots now are going to be able to be right at the very edge and cut off the canvas. So that's why you need to stop at 400. And if you divide 40 into 400, you're going to get 360 as an even amount. So you want to make sure that you don't go further than that. So you want to make sure that both of your loops are going to stop at 400 for the limit of the loops. You notice that when I ran the code, I got some print statements down here at the bottom, and I have those in there on purpose because I want you to see how the values in the loops change. Now, the loops are identical in the way that they both have the same starting values. They both are going to stop when they reach 400, and they're going to be incrementing. The step values are both going to be 40 because you can see that they're evenly spaced. Okay, so there's 40 between each circle, moving X to left and right and moving Y up and down. So let's take a look at the print statements down here so you can see how the values change. So I start out with my outer loop, which is going to be my first X value, and I use X and Y to draw my circle. So I'm using the counter variables on the loops to actually draw the circles on the grid. So here I've got my X, which is going to start at 40. And then I get my first value of the outer loop. I have to go inside to my outer loop, and then I have to hit my inner loop, and I have to finish every repetition of my inner loop before I move to my next repetition of the outer loop. So you can see here how the Y values change. So first I get of X40, and then my Y for the first repetition of the inner loop is 40, and then I go to the next repetition of the inner loop, and that keeps changing until I hit my last value. And if I move down here, you can see that I hit 360 for Y, and then when I add that next 40, it's going to not pass this condition on the loop. It's going to say, oh, well, if I add 40 to 360, you're going to hit 400, so you're not allowed to do that last repetition, and that's when it's going to jump out of the inner loop and go to the next repetition of the outer loop. And here then we go to X, which is going to be 80. Okay, which if you look at your grid, you're going to be sitting right here over at the very top at an X value of 80 and a Y value of 40. So we get the next X value, we hop back into the inner loop, and we draw all the circles again, moving down until we hit that limit of the inner loop. We jump out of the inner loop, start over with the next repetition of the outer loop. And we continue till the outer loop reaches its limit. And when it reaches its limit, we've drawn the entire grid. Okay, so you can see how putting the print statements in here can really help you understand how these values are changing and how you're using the counter variables on the loops to actually draw your circles on the grid. So the next thing we need to worry about is the second part of the project, which says resize any dots that touch the glass to be larger. And what we're going to do is I'm going to put the code in, and then I'm going to go over it with you so you understand exactly how this works. Now, we have to see if there's an intersection of the magnifying glass and the dots on the grid. So what we have to do is we have to use another for loop. And this is not a nested loop. This is just one loop that's going to loop through the dot grid, which is a group. So all of the dots are part of a group. So we want to read through every single dot that's part of that dot grid. And we want to check to see if it's hitting the glass. So if there's an intersection of any points of the magnifying glass, which is another group, and you can see that that's defined right up here, which is just a circle and a line, but it's a magnifying glass group called glass. And what you're going to do is be checking to see if that's true. So, and we use our hit shape, which is a function that we learned about earlier back in a prior lesson, which is going to check to see if any of the points of the one shape are going to intersect at all with the second shape. So we're checking to see if any dot in the grid is going to intersect with the magnifying glass. And if that's true, we're just going to change the radius of the dot to make it larger. And that's pretty much it. And if there's no intersection, we're just going to keep our radius at 5. So you can see now if we run this, we should see now if I run what's on the canvas, how when I move my magnifying glass around, my dots now get larger. Okay, so you might have to review, and when you're looking at the problem statement, you might have to go back in the course and take a look at how these different functions or methods work, because we've learned a lot of them, and sometimes you don't always remember how to set them up. So that's why you have your course docs, and you can always go back in the course and read about hit shape and see how that works. So you might need to go back and do that if you don't remember. But that's pretty much the magnifying glass application. What we did was we set up some nested loops. So hopefully you have a better understanding of how nested loops work now and how you can use the counter variables to actually plot drawings on your grid, and then how to use this hit shape to determine if there's any intersection, and you use another loop to read through all of the dots on the grid in order to determine that intersection. And that's it.